So there we go. Here we go. All right. So this is question. It's on 4.1 and it is homework question.
17.
There you go. Okay. So I'm gonna label it here. So this is on the video, so we can go through and do this. So volume area. So we're doing the derivative of the volume right here. That's gonna give me, what's the derivative of this?
Of the volume, it's 12
Yeah, I'm sorry. Thank you.
over
It's not going to be 12 though. Why is it not 12? It'd be 12 over what? 12 over 3. What's 12 over 3? Yeah. So when I take this and multiply it, I can cancel out the 3's. Make life a little bit easier. So it's going to be 4 pi r and there you go. There you go. So that's going to be important. Now let's look at the variables that I know already. Do I know what the dv dt is? Yes. Do I know what r is? Yes. And so the only thing that is going to be the unknown, which I'm going to solve for here, is going to be my dr dt. Okay? So let's plug it in. So that right there, I'm going to get 1.5 equals 4. Oh my goodness. 4 pi 4 squared dr dt. And what's that going to be like? 16 times 4 is 64. 64 pi, right? Okay. So I'm just going to leave it like this. 1.5 divided by 64 pi is equal to my dr dt. So I'm going to leave it like this because that's not the one I need. I'm just going to leave it as an exact answer there. I don't need that. So let's go back up to the area problem up here. And now find the derivative of the area. So that's my end goal that I'm going for. So I'm going to get a dA dt is equal to, as I do my derivative, I get 8 pi r dr dt. Do we know what r is? Do I know what dr dt is? Now that I have that, I got that from my volume, and so I could actually do it in here. So now, as I plug in everything, it's going to be dA dt is equal to 8 pi, hold on. Eight pi r is going to be 1.5 over 64 pi times my r, which is 4. This board's messing me up big time. Now I put the dr dt first because I want you guys to see what can I do with that. Can I cancel some things? I can cancel the pi's, right? A pi on top and a pi on bottom, right? And I have an 8 here, and I have 64 here. Do a little bit more canceling here. So what's that going to be? 1.5 divided by 2, which is going to be 0.75. And if this is my dA dt, my dA dt is going to tell me that this is, what is it? Unit squared. What are my units squared though? Okay, yeah, meters squared per, there we go, yes. Very good. Yeah. It is? Yes. So it already told us that it's actually emptying. So it's leaving the volume. So if I wanted to actually include that negative, I could have, which would have been right here. So then I know that it is going to be shrinking. So from the word problem, I got it, and I already know and I understand that it is shrinking at that. So yes, we did everything the same. So it's just my rate that it actually is going, it's going to be a negative, so it is shrinking at that. So the positive and negatives are important. Okay, for right here, yes, you did bring up a good point that it is shrinking at this. I didn't need the negative, but I could have used the negative. Either way, yeah, it's just knowing that it's shrinking. It's kind of like something moving to the left or to the right. So in all the problems that we're doing, everything in motion is moving to the right, which is going to be a positive, and anything moving to the left is going to be a negative. You're going to see that on the next example. Okay. All right, are you good? Kind of answer the question, Christian? Okay. All right. Anyone else? Did you start in chapter 2 last night, or no? You got like. Yeah, you just needed the book to go look through the videos for chapter 2.
Oh, I looked through them, but I didn't take notes on them, so
Ah,
I'm probably
okay.
gonna do that.
You'll be fine. I'll hopefully my entire thing's not corrupt. So
I see number
19,
19.
yeah.
Idea. I'm still confused on the whole problem.
19.
Yeah.
A ladder leaning against the wall. Lower end slides away. This one actually has a diagram, so that's actually very helpful. So I have a wall leaning against the ladder's 5. And it gives me a theta over here. This is going to be an x. This is going to be a y. And it says it's moving in which direction? So this is going this way. And this is going this way. If the lower end of the ladder slides away from the wall at 0.5 meters per second. So dx dt is 0.5 meters per second. At what rate is the inclination theta of the ladder with respect to the ground changing when the lower end is 4 meters from the wall? So we're looking for that right there. I think I got them all. Okay. What type of triangle are we dealing with here? It's a right triangle. Okay. So let's use some trig. You guys remember that trig stuff? Okay. You guys remember the acronym for that one? So it's some old hippie caught another hippie tripping on acid. So from my reference angle, which is theta, do I want anything to do with x? Yes, I want x in my problems, right? So from my reference angle theta, which is right here, I want to use x. So which side is that? That's going to be the adjacent, right? Okay, so I have to use an adjacent. Do I want to use the y? No, I don't want to use y. Okay, so what do I want to use? The hypotenuse? Yeah, I want to use the hypotenuse. So I don't want to use y, so I don't want to use the opposite, right? Because I don't want to have a y, I don't want to have a dy dt, because y is changing, isn't it? So I don't want to use it. If I don't have to, I'm not going to. So I'm going to use the hypotenuse instead. So I'm going to use the adjacent and hypotenuse. What is adjacent hypotenuse? C, right? So cosine. So let's write out my problem that it's going to be setting it up. So it's going to be cosine of theta is equal to adjacent over hypotenuse, which is x over 5. Yeah? Okay, good. Alrighty, let's go ahead and do a little math then. So, let's see, multiply both sides by 5, make my life a little bit easier. So 5 cosine theta equals x. Take the derivative. What's the derivative of cosine? Yep. Okay. So we know x is 4, right? Yes, Juju? X is 4. What's y going to be? If x is 4, the hypotenuse is 5, what's the y? Yeah. So this is those special triangles, so 3, 4, 5. So this is a 3 here. Okay. So we're using this. So now, sine of theta. Sine of theta. What is sine of theta? Sine is opposite over hypotenuse, right? So if sine is opposite over hypotenuse, my opposite is, and the hypotenuse is negative 5, 3 over 5 d theta dt is equal to dx dt, which is going to be 0.5, right? Cancel those, divide by negative 3, and I get d theta dt is equal to 0.5 over negative 3. Is it negative 1 over 6? And what are my units?
Rad over second.
Rad. Second. Right.
Can you go over 10 more?
Huh?
Can you go over 20 more?
I can.
Like extremely quick.
Yeah, that's another pull one. Alright, we good? Alright, so. You said 21? Yes, Tree? Okay. Alright, filling a pool, 30 meters long, 5 meters wide, depth of 3 at one, and 1 at the other end. Water is pumped into the pool at a rate of 15 meters cubed per minute. How fast is the water rising when use figure 4 as a guide? So, and that's the one that we did, figure 4. Yeah, that's the pool problem that we did. So it's the same as the pool problem. So it is 30 by 5. So I'm going to start by drawing here. So the top view is 30 by 5. Side view is 3 and 1.
Actually, do you have the note from yesterday?
Huh?
Do you still have the note from yesterday for this problem 6 on the paper?
Oh, on the paper? Yeah. I also post the video too. Water's pumped in the pool at a rate of 15 meters cubed per minute. So that is my dV dt 15 How fast is the water level rising? dH dt is what I'm looking for. 1 meter deep in the deep end. So that means H. There we go. So let's go ahead and start by looking at the parts of the pool I'm going to be using. This is 1 meter here. I don't know what the length is going to be though, right? So we're going to do the ratio again to try and figure out what the length is supposed to be. So remember, the ratio changes. So the height and the length are changing proportionally. Yeah? So the height of this triangle right here, the height of that triangle, okay, the height would be what? 2, right? The length in this case is 30. So it's 30, it's going all the way across here, right? So over 30. So doing the same thing with the proportions to replace one of the variables, that's what I need to do. So I get 2L equals 30H, and then, because I want H's, I don't want L's, 15H. This is L. This is my length. This is also the length right here. But the length is proportional to my height, which is right here. So the whole thing right here is my height gonna be. But that's what we're talking about with the proportionality with just this triangle here. Because at this point it changes. When it finally gets to this, then it changes. It's no longer going to be proportional. The L is going to stop at 30. So down over here, L is like 1, but by the time I get up to here, when H is 2, L is 30. Okay, all right. So we're going to do the volume problem. So setting up the volume, it's going to be area of that triangle, which is 1/2 H times L times width. And on this pool right here, is width a variable? Say no. No, it's not a variable. The width is, it's just 5, right? Okay, that's the width of the pool. That doesn't change. It's always going to be 5, no matter if I'm in the deep end, the shallow end. The whole pool is 5 all the time. So that one's not going to be a variable. So I'm going to just replace it with a 5 because that doesn't change. The L, I'm going to replace with my 15H, right? So rewrite it. V equals 1/2 H times 15H times 5. Yeah? Were you okay still? Alright, so what's that? 75 over 2? V equals 75 over 2H squared. Now do the derivative, and I'll let you guys do the derivative, so give you a second on that. You almost got it, Christian? Sherilyn, you doing okay over there? Alright, did you get it yet? No?
I got it.
Did you get the derivative? Oh. Alright, derivative dv dt is going to be 75 h dh dt. So, let's plug in what I have. Plug in what I have. 15 is equal to 75 h, which is 1, dh dt. Is that 1/3? 1/5.
Yeah, 1/5.
1/5. Okay, so what are my units? Meters per. So that's saying that my height,
And why is it meter over here?
what are my units?
Why is it
I know, what are the units?
meters?
Meters, right? And the height is measured in a linear, right?
Okay.
Okay. If it was a volume, it would be meters cubed, but it's not a volume measurement.
And area?
Area would be a square, right? There you go. Yay! Productive day. A lot of homework. So Monday, I gotta finish the notes on Monday, and that means homework will be due on Wednesday.
Just one, so, the FRQ and the MCQ were in
Yeah.
line.
Yeah. So you gotta get those done. Did you guys do was it skill check? Something check,
This
progress check or something like that, right?
Okay.
On the AP Classroom?
Oh, that's the FRQ and the MCQ, okay.
Yeah. The multiple choice is MCQ. FRQ is a free response.
Okay.
So yeah, make sure you remember it is due today. So, and it's not for a grade, it's just, you're gonna do it, and then I can see where we need to work on. Okay, so you get credit for actually just doing it. Okay, I'm gonna stop right there. I'm gonna make sure everyone likes, shares, and subscribes, hits that notification button, supports my channel. Buy stuff for the merch store, which is supposed to be closed down, but it hasn't happened.